NASA has found a super-Earth that could have conditions to support life. The new exoplanet is 137 light-years away, or about 800 trillion miles. Cosmologists say the planet is approximately 1.5 times the size of Earth and orbits a little ruddy star cooler than our Sun. NASA's James Webb Space Telescope has scarcely begun its operations, and the universe already appears more puzzling and beautiful than humankind's wildest fantasies. It's an incredibly thrilling discovery. While we haven't found an exact twin of Earth yet, this planet is not an accurate replica either. However, among the latest batch of 500 new potential planets, this one, slightly larger than Earth, stands out as a tremendous revelation. It is an enormous discovery, highlighting how this exceptional instrument in space is finding phenomena that challenge our understanding of the universe. The James Webb Space Telescope, JWST, is so powerful that, with enough time, it could potentially discover any world that has ever formed in the universe. Recently, the telescope captured something extraordinary: lights resembling those from a city glowing from a distant 0.7 trillion miles away. This revelation has sparked interest in the possibility of life beyond Earth. The telescope focused on Proxima Centauri b, the closest exoplanet to our solar system, and discovered strange, bright lights. Could these lights be evidence of another civilization? Let us explore how the James Webb Telescope uncovered these peculiarities that may transform our understanding of the universe. For years, researchers and enthusiasts alike have eagerly awaited a glimpse of what life beyond our solar system might look like. Any small piece of evidence hinting at such a possibility was welcomed with excitement. Then came a pivotal moment. The James Webb Space Telescope revealed compelling signs of life elsewhere in space. As it scanned the vastness of the cosmos, this powerful telescope spotted something fascinating on Proxima Centauri b, an exoplanet far away. It observed lights that appeared similar to urban city lights on Earth, suggesting the possible presence of an alien city on this distant planet. This idea has generated excitement among scientists, as it might represent the kind of discovery they have been hoping for: evidence of intelligent beings organizing their societies in ways we have yet to comprehend. These distant city-like lights, located a stunning 7 trillion miles away, have amazed NASA experts, who are now pondering how long these lights have been visible in space, waiting for us to develop the technology to detect them. David Kipping, an astronomer at Columbia University, described the planet where these lights were observed as extremely complex. Unlike most rocky planets that absorb sunlight and release infrared energy, this exoplanet behaves differently due to its unique relationship with its host star, Proxima Centauri. This discovery underscores the significance of the James Webb Space Telescope. Its ability to capture infrared frequencies was crucial in detecting Proxima's unusual thermal signature, which is essential for understanding the planet's environmental conditions. Scientists plan to use the telescope to delve deeper into the atmosphere of this planet and investigate its habitability further. The James Webb Telescope is particularly sensitive to infrared light, allowing it to observe what happens on Proxima Centauri b during the night. For many space telescopes, it is challenging to detect faint lights in the vast darkness of space, but the James Webb Telescope can spot even the smallest flashes of light. This makes it an ideal tool to confirm whether the alleged city lights on Proxima's dark side are real. The telescope can detect any artificial light in space if it falls within a very narrow frequency band, much narrower than standard starlight. Proxima Centauri b has a unique relationship with its star. On the daytime side of the planet, various solar panels capture the star's energy, while its spectral edge reflects light. As the planet orbits Proxima Centauri, it experiences day and night cycles like those on Earth, with intense heat during the day and cooler temperatures at night. The planet experiences significant temperature variations, determined by its composition. For example, if Proxima b lacked an atmosphere, the temperature differences between day and night would be extreme. Without the moderating effects of atmospheric gases or oceans, the day side would become incredibly hot, while the night side would plunge into frigid temperatures. This dramatic temperature variation is of particular interest to cosmologists, as it provides insights into Proxima b's atmospheric composition. The James Webb Space Telescope, with its unmatched infrared imaging capabilities, can analyze the planet's thermal emissions, providing valuable data about its atmospheric properties. Interestingly, the telescope's orbit around Earth coincides with Proxima Centauri b's orbital period, allowing for extensive observations every 11.2 Earth days. If the planet indeed has an atmosphere, the next step will be to examine its atmospheric chemistry to determine if it can support life. Signs such as the presence of oxygen, water vapor, and methane would indicate habitable conditions. If these elements are found on the planet, it would confirm its potential to support life. This requires precise capture and analysis of light passing through the planet's atmosphere, a challenging task. Although the James Webb Telescope excels in characterizing planetary atmospheres, it is primarily designed for other tasks. It specializes in analyzing variations in water vapor, carbon dioxide, and methane concentrations. While it has some limitations in detecting bonded oxygen, a crucial indicator of life, it is also equipped to search for other key elements like ozone, a strong marker of a healthy atmosphere. Researchers consider the James Webb Space Telescope's discoveries a significant pursuit in investigating distant universes. This endeavor brings us closer to understanding whether we're alone in the cosmos. While the telescope explores new worlds, it's essential to remember that it can observe only a limited number of the closest habitable planets to Earth. For more detailed atmospheric studies, astronomers are turning to ground-based observatories like the Extremely Large Telescope (ELT), set to begin operations in 2028. The ELT is designed to provide deeper insights into the atmospheric patterns of distant exoplanets, offering precise and clear data on their potential to support life. Researchers eagerly await the ELT's activation. Meanwhile, the James Webb Space Telescope remains a vital tool in our quest to explore far-off exoplanets. Despite its limitations, it continues to offer crucial insights that could reshape our understanding of what lies beyond our solar system. Scientists have grand plans for the space telescopes of the future. They aim to suppress the blinding brightness of stars to better observe the planets orbiting them, much like using a hand to block sunlight on a bright day. By reducing starlight, these future telescopes will have a clearer view to study the faint light reflecting off distant planets, helping scientists analyze planetary atmospheres and determine if life might be possible. However, this task isn't simple. Researchers must differentiate between gases produced by living organisms and those from natural planetary activities, like volcanic eruptions. They are deeply committed to learning more about these distant planets so they can identify true signs of life, rather than being misled by natural processes that mimic biological signals. The Webb telescope offers us a glimpse of what these future investigations might reveal. As we continue to push the boundaries of our knowledge and exploration of space, we come closer to comprehending the universe's complexities and our place within it. From the beginning, humanity has pondered whether we're alone in the universe, a question that drives many scientific endeavors today. Currently, the James Webb Telescope is examining various planets and moons to determine if any might host alien life. Many now believe that extraterrestrial life could indeed exist somewhere in the universe, waiting for us to find it. To answer this age-old question, two American astronomers, Jill Tarter and Thomas Pearson, launched the Search for Extraterrestrial Intelligence (SETI) project in 1984. They established a foundation to listen for radio waves from space, as radio waves can travel vast distances without getting lost or absorbed. They utilize the Allen Telescope Array in California's mountains, a set of 42 radio telescopes dedicated to this purpose. Despite over 30 years of searching, SETI hasn't found any signals that definitively indicate extraterrestrial origins. Still, Jill Tarter remains hopeful. She believes that with today's technology, they may finally discover something. She even encourages everyone on Earth to participate in this exciting search for companionship in the universe. Recently, excitement grew when NASA reported that the James Webb Space Telescope might have detected city-like lights on a planet not too far from Earth. The JWST is currently our best tool for space exploration, positioned 1 million miles from Earth and transmitting detailed information about the oldest parts of the universe. It's specifically designed to capture details we previously missed, helping us understand how galaxies, stars, and planets form. Astronomers are utilizing the JWST's advanced technology, such as its high-resolution camera and unique filters, to examine and interpret subtle colors around stars and planets. They rely on this telescope to learn about the physical and chemical compositions of places light years away. By isolating specific light wavelengths, the Webb telescope isn't just observing, it's actively scanning the atmospheres of different planets for the faintest hints of life. Using its unmatched capacity to peer through time and space, it has already made some remarkable discoveries, such as finding significantly more mass hidden in giant galaxies than previously thought. This has prompted scientists to reconsider some of their theories about how the universe began and evolved. With every new discovery from the JWST, our drive to understand distant planets grows, expanding what we know about life beyond Earth. Humanity is now using the JWST to venture deeper into space than ever before, gathering information on distant worlds and providing insights that could answer fundamental questions about these remote planets. Decades ago, we knew little about planets outside our solar system, yet since then, astronomers have discovered over 4,000 exoplanets orbiting distant stars. NASA believes these discoveries are just the beginning, estimating there are likely trillions of exoplanets waiting to be found. Scientists haven't stopped their space exploration, hoping to discover places where extraterrestrials could exist. Occasionally, they receive hints that they may be on the right track. For instance, when the Galileo spacecraft journeyed to Jupiter, it accidentally detected a signal that could indicate vegetation. This was a significant discovery, as it was the first time a biosignature, known in this case as a vegetation red edge, was detected. This technique, the VRE, observes how light reflects off vegetation in a unique way. With the help of VRE, the James Webb Space Telescope is poised to reveal more about the potential for life in space, mapping orbits of planets in the habitable zones around their stars. If these indicators emerge, the virtual reality engine V could truly revolutionize space exploration, guiding us toward intelligent life beyond Earth. Picture this. Sunlight streams through various atmospheric layers, splitting into rays of different wavelengths that atoms and particles in those layers absorb. This ongoing process creates a unique spectral fingerprint that we can interpret using a technique called spectroscopy. Many scientists are confident that when starlight reaches a planet's atmosphere, the Webb telescope will capture that light as it filters through the atmosphere. This glimpse into the planet's interior means the JWST could be the crucial piece we've needed to understand what distant planetary atmospheres are made of. Planets about the size of Earth typically have atmospheres with carbon dioxide, nitrogen, and oxygen, making them potentially capable of supporting life. But the absence of familiar compounds might suggest entirely different types of organisms or even advanced civilizations. For example, chlorofluorocarbons, CFCs, are synthetic chemicals primarily used in refrigeration. If the JWST detects these artificial substances in a distant planet's atmosphere, it could be undeniable proof of intelligent life beyond our solar system. Such a discovery would broaden the scope for astronomers, offering them a whole new playground to explore planetary atmospheres and even the faint possibility of civilizations far beyond the Milky Way. Contemplating life beyond Earth opens up possibilities that go far beyond what we know and experience in science here at home. We often imagine life needing a temperate environment to flourish. Yet reality might be far more diverse. Extremophiles, for instance, are resilient bacterial life forms that defy our conventional ideas about suitable habitats. These resilient creatures manage to survive and even thrive in conditions that would seem apocalyptic to other forms of life, enduring extreme heat up to 250 degrees Fahrenheit and thriving in highly acidic environments with pH levels below 3. Their existence is a powerful testament to how adaptable life can be, even in the harshest and most unforgiving conditions. As the search for life-supporting worlds takes new directions, the possibility of finding life in unexpected places challenges our understanding of the universe. The vastness and diversity of space suggest that our search for life must be broad and comprehensive. Planets that resemble Earth and orbit stars like our Sun are excellent places to begin. However, it's also crucial to keep an open mind and consider unconventional scenarios, such as investigating exoplanets that orbit red dwarf stars, which are common across the universe. Although these stars aren't as bright or warm as our Sun, they offer unique settings to explore life's potential in diverse environments. Their longer lifespans provide ample time for the slow, complex processes involved in the evolution of life. Take the TRAPPIST-1 system, for example. It features a faint red dwarf star with 7 rocky planets, much like Earth, orbiting it. Of these, 3 are thought to be in the habitable zone, meaning they might have liquid water on their surfaces. Despite being smaller and cooler than the Sun, the TRAPPIST-1 star emits a gentle light that could support life. By studying the light emitted by the star, scientists hope to uncover clues about the living conditions that might exist within the TRAPPIST-1 planetary system.